Okay, let's go to the surface area of a pyramid. A pyramid is a solid with polygonal base and slanting sides that meet at a common apex. When I talk of a polygonal base, I'm assuming you know what polygons are. This base can take any shape so long as it's a polygon. And for us to be able to find the surface area of a pyramid, you find the sum of the area of the slanting faces. Soon I'll let you know what are the slanting faces, plus the area of the base. If I happen to go to a net, like if you look at this pyramid here, it has a square base, then it has other four faces. There is this face here, there's another face on this side, there's another face there, and the other face on the other side. Those are four faces. So you have to understand the difference between the perpendicular height and the slant height. When you look at this pyramid, you realize if I drop height from the apex to the bottom or to the center of the base, that one I call it the perpendicular height. Then again, if I open up now, you'll realize if I look at this solid, the whole of it, you realize now the slant faces, they have another height. And again, you can also introduce another perpendicular height of each face when you are finding the area. So of concern here should be the ability of the students to relate the perpendicular height and the slant height. Also importantly, for us to be able to find the surface area of a pyramid, we also have to understand the concept of the net. It will be very important for us. I know you did nets sometimes and it will be able to help. For instance, if I open a solid like this, if this is the base, then I have this face here. You realize I can also drop another perpendicular height for me to be able to find the area of this face here. For me to be able to find this face here, right? For example, I have this is my slant height, this is my slant height, this is one of the bases. Then of course from that I'll be able to find this height here, and I use it to find the area of this. So for us to be able to find the surface area of pyramids, the knowledge on nets will be very important. For example, let's find the surface area of the above prism, the one we have here now. The one I have here whose base is 4 and the slant height is 8. The surface area, I want to introduce you to nets. I know you know how to use nets, but I want to make your life simple. The surface area will be given by the base area plus the area of the 4 slanting faces. I have 1, 2, 3, 4. Now, the area of the base, but before I get to the area of the base, let's see, for us to be able to find the area of the slanting faces, something is missing. The height here is missing. So where do I get the height? This one I have to get to, right? Pythagoras comes in, then this remains 8. So the height will be 8 squared minus 2 squared, square root of these two, which gives me 7.746. So the surface area will be the area of the square base, 4 by 4, plus a half by base again, 4, times the height here, 7.746, times, how many are they? 1, 2, 3, 4 times the 4. And this gives me the total surface area of this pyramid to be 77.97 centimeters squared. I want you to go to your KLB books, example 3, page 179. Try and do it for me. Again, I want you to be able to relate. Not all the times you'll be given the slant height. Sometimes you'll be given the perpendicular height of the solid. Then it's upon you to relate the perpendicular height and the perpendicular height and the slanting height to come up with whatever is missing. So go to KLB book 3, example 3, page 179. Solve example 3. Study the example keenly. Try to follow and see whether you understand. That one forms your class exercise.